Okay, so in this next video, I'll briefly walk you through about the several critical parts with respect to implementation. Okay, using the terminal. So assume right now I've already successfully logged into one of the Zeus servers. In this case, is Zeus 1, right? And right now, I'm under os161 minus 1.11 directory. Okay, so the next project, a thread-based synchronization, traffic-like synchronization problem. There are these several places that you need to modify the source code and perform your implementation, right? So if you change directory to current and thread, under thread, this is path, right? Under thread, we have sync.c and thread.c. So sync.c is a source file which implements the several important sync primitives, including semaphore and log. And recall that in the previous video, we've talked about you need to implement the log primitive by referring to the implementation of the semaphore. And we've gone through the implementation of semaphore in the previous slides, right? So the definition of the semaphore APIs is within this source file. So as you can see, we have semaphore create, semaphore destroy, P, which is associated with semaphore wait, and also V, which is associated with semaphore post. And so that completes the section for the semaphore implementation. And the next section is, belong to the log implementation. And you will be asked to implement, to fill out the correct logic within these several important log-related APIs. So as you will see, we've already left the comments over here, right? Add stuff here as needed. So this is where exactly you need to put in your implementation, right? So basically you will be implementing log creator, which is used to implement, which is used to initialize a new log. And then log destroy is this is where you reclaim and destruct an unused log, right? You've already done with using that log. You want to destroy it before quit, right? Use log destroy. And the next two important APIs are log acquire and log release. So just make sure that you want to use the interrupt disabling and reabling logic to implement this mutual exclusion guarantee kind of logic. Okay, and note here in this specific project, you should implement the traffic light problem only using log. You should not really use condition variable or semaphore to implement that. So the rest part, the condition variable, you could pretty much disregard the next part, okay? So next, let's zoom in and take a look at the several important APIs within thread. So this thread.c source file is where all the thread-related APIs are implemented. At the very top, if you take a look at over here, it defines all the three important states of any thread within os161. So we have run state, we have ready state, and sleeping state, which is basically thread getting blocked. Okay, and we have a fourth state, right? So this zombie state means it's an orphan thread that needs to be cleaned up, but it's slightly, it's out of the scope for this particular project. So we don't want to take a look at this within this project. And as mentioned in the last video, we have this global variable, which is called current thread. This is where the operating system keep track of this currently running thread because OS161 assumes a uniprocessor architecture, right? So at any single point of time, there's only one thread that is actively running. And besides that, we have a sleepers queue and we have a zombie queue. And this global variable is used to keep track how many threads in total have already been created within OS161. Okay. So let's directly move on to the interface thread fork. This is where you create a new thread. And we've already talked about the signature of this API, right? And if you want to pass in any arguments to this newly created thread, you should specify the second field, data1, and the third field, data2. Okay, so if you are interested, feel free to take a look at how exactly thread fork gets implemented. And as it will become critical in our next assignment, where you will be asked to implement process-related APIs, process fork, a process wait, and so on. So it serves as a good starting point for the next project as well. Okay. Well, that is the thread directory. So with respect to the next this project, the next place that you will be looking into is this directory, which is called assignment 1, 8SST1. So this directory contains several source code, source files, and we've already seen this cat mouse simulation program, which is defined within catsam. Right? So these defines, the corresponding thread function routines that is implemented for simulating this cat and mice program. Right? As you can see over here, it calls thread fork to create several cats over here. And you specify the name of the thread and then the index of the thread, and then followed by the function pointer, which points to the exact implementation of this cat thread. Okay, just show a typical usage of the thread-related APIs. And the next section, the next part, it simulates the mouse-related API, the mouse-related logics enters into the for loop in mice number of times, and each iteration creates a new mouse thread. And similarly, you pass in the index for this mouse thread, and the next parameter is the implementation, the function pointer that points to the this thread implementation of the mouse thread. Okay. So, but that just showcase how you should really use thread fork API. So what you should really look into in this specific project assignment is this stoplight.c source file. So basically, just provide a we provide you with a source code template, and you are responsible for filling out the corresponding parts with the comments that asked you to fill out, right? So at the very bottom, we have this most important APIs, which is to create cars. This is where exactly the cars get created. So it's essentially a for loop. It loops this much number of times, n car number of times, and this is a macro which is defined up front, which defines the total number of cars. It has a default value which is 20, which means by default you should create 20 cars, but you are more than welcome to increase this number to stress test your implementation. Say you specify 500 or 1,000 200, these many number of cars to stress test the logic of your lock as well as your stop light, logic. Over here, it calls thread fork to create this many cars. And the most important, so this fourth field, it specifies the name of the function that implements each car approach intersection, which is defined up front, right? Over here. So this is where you should, implement this approach intersection logic. And besides that, this call should really call the other helper functions. So we define a few helper functions which specify the behavior, how exactly you should, let's say, go straight, make a left turn, make a right turn, right? So these three different behaviors as you approach intersection. So you are responsible for implementing those APIs as well. Okay. So let me see what else. Oh, so in order to, compile assignment 1, so as typically, as you've done for the previous assignment, just change directory to this current/conf, right? So we have the configuration file for each and every different project assignments. So here we are interested in assignment 1. So just do config ASST1. So this will populate a directory under compile/assignment1. So just change directory to the parent directory and change directory compile assignment 1. Right? So I just make clean, remove all the previous build, and then do make depend. Okay, this will generate the corresponding depend related make files, and then make and make install. So here I put these two ampersand together to concatenate these two commands together, so that the shell will run these two like in serial in order. Okay, so it will just first build it and install it. Build by using make and install to just copy the binary into the root directory by following this make whitespace install command. Okay, so if you check the return, if you check the return value of the previous command, it shows 0. It means everything works out fine, right? So just go to home directory, os161 root, right? So this is where the compiled os161 binary executable is located. If you check the timestamp, it shows like right now it's 5 p.m., 5:08 p.m. It's a newly compiled kernel. So, but before get started running this binary, let's first take a look at this important configuration. So this is the runtime configuration file, which is called sys161.conf, which is also located under the same directory, this root directory, which is used to contain all the binary, the runnables, okay? So here I've already made several important modification to this configuration file, which is directly associated with this project assignment. So the very first update that you should make to this configuration is you need to change this random auto seed into a deterministic seed value. You could use a seed value of 1 instead of assigning different seed values. Like each time you test your stoplight code implementation. So this will generate deterministic behavior rather than like non-deterministic random numbers. Okay, so this is the first that you want to modify. And the second place that I made a modification over here is I comment out the last line, which only used to configure, which is used to configure only half a megabytes of the DRAM for os161. Instead, you want to increase your DRAM so that it won't be running out of memory. So in this case, I changed the DRAM size of the operating system from half a megabytes to 2 megabytes. Okay, so I've also included all these hints, text-based description in our in this project assignment spec. So make sure to walk through to read all the text description carefully. Okay, so next let's try to run the already built kernel. This is os161 kernel. So this running, it prompts you at the menu, at the end of the menu. So you just type question mark, which shows you all the different available kernel menu, the list of kernel menu. Okay, so let's first do question T to check this task value. So what we're specific interested in this assignment is SY2, which is the log test, right? If you type SY2, it will show some random message, but eventually it will fail. Task fail over here, right? Because the log implementation is empty, is effectively empty. So the very first thing that you will make sure to finish is to implement a correctly behaving log, okay, to pass this log test SY2. Okay, so let's prompt this kernel value again. So another option is 1C, which is over here. So this is option which triggers the test for stop light implementation of your code. So if I type 1C, it will just directly print out a single line of message. Operation took this much time without printing anything because effectively my stoplight implementation is empty, so it won't be printing out anything. But as long as you've done with your implementation, make sure to generate meaningful messages so that the GTA can use to check the correctness of your implementation. And you are also welcome to change ncar's macro to a larger number from 20 to say, to say 200 or even larger to stress test your implementation. Okay.